Hello everyone, this is our 52nd video tutorial under the GCSE topic revision guide called Circle Theorem Proof. In our last topic 51, we have discussed about circle theorem and finding the missing angle. But in this topic, we are going to understand the proof of circle theorems. Altogether, you need to know proof for 7 circle theorems, but in this video, we are going to discuss the first 5 theorems and we will discuss the remaining 2 theorems during our GCSE revision class. Let's look at the proof. This is the tutorial we are going to discuss in this video tutorial. You can download this tutorial from our website at www.smarttutorscom.uk/worksheet.php. The yearly membership costs £24, which will allows you to download all the tutorials from our website. Let's look at our first question. Question number 1. Prove the angle subtended by an arc at the center of circle is twice the angle subtended at any point on the circumference. So the circle is drawn here. So all the construction lines, you have to do it by yourself. So the main idea here, I want a center and A, B, C are the 3 points in the circle. So I marked it. So A, B connect the line and AC connect the line and BO connect the line and OC connect the line. Then AO extend that line connected here to the circumference at D. That's all we need, right? So let's just go through the diagram again. The radius is AO and OB, OC are radius. So the radius are equal because that's a circle. So I put a mark here, line and line. That means those 3 lines are equal. First, let's look at the proof very carefully, because if this question comes in the GCSE paper 2 or paper 3, it's going to be a 7 marker or 6 marker, right? So you have to understand each and every step very carefully. Let ABO equal X. So let ABO is X. So BAO also X because it's an isosceles triangle. So isosceles triangles mean the base angle is going to be equal. So AOB, which is going to be 180 minus X, which is 180 minus 2X, because angles in a triangle add up to 180. Same as you can prove AOC is going to be 180 minus 2Y. So if you see BOD equal 180 take away 180 minus 2x. So 180 is a straight line, take away 180 minus 2x, which is 180 minus 180, minus time minus is plus 2x. 180 cancel, so 2x is the answer. So the 2x is going to be somewhere here, BOD. So that is the BOD is 2x. So now we are thinking about the next step, same as DOC, you can prove that is going to be 2y, right? So BAC, it's going to be x plus y, and BOC, it's going to be 2x plus 2y if you factorize 2x plus y inside the brackets. So therefore BOC is equal to twice of BAC according to this one. So it's 2x plus y and just x plus y. So the theorem is true. So the center angle equal to twice the circumference angle. So that is the proof for the first question. Second question, prove the angle subtended at the circumference by a semicircle is a right angle. So in this one you need to draw a circle and the constructions lines are, you draw a diameter which is passed through the center, which is the AOB is a straight line which is passed through the center, which we called as a diameter. So connect the A to C. C is a point in the circumference and C to B is also line connected. if you see O to A, OA, O to C, OC, O to B, all the lines are equal length, right? So OAC equal X, then ACO also X. So because this is a isosceles triangle, so triangle AOC is an isosceles triangle. So I forgot to write that one, so I write that one here now. Isosceles, right? So isosceles triangle means it's going to be a base angle are equal. Let OBC, this is Y, then this also isosceles triangle, so this also Y. So BCO is also Y. If I add all three angles of the big triangle, so which is the BAC is this angle, then BCA, this the total angle, then ABC is this Y angle, all together add up to 180 because angles in a triangle add up to 180. So if I mark it, BAC is X, BCA is X plus Y, ABC is Y equal 180. So if I add all three angles is here, X plus X is 2X, Y plus Y is 2Y, 180. So 2X plus 2Y equal 180. So 2X plus 2Y means if you factorize, it's going to be 2X plus Y equal 180. So if you divide both sides by 2, X plus Y equal 90. So X plus Y means ACB, which is ACB equal 90 degrees. Therefore, angle subtended at the circumference by a semicircle is a right angle. Question number 3. Prove the angles in the same segment are equal. So angles in the same segment mean this CAD, that angle, and CBD, that angles are same segmented angle. So how can we prove that one? Let CAD is X. COD, so COD is 2X because center angle double the circumference angle. So CBD equal half of COD. So COD is 2X, right? Half of 2X is X. So basically it's a two parts of theorem. So you need to make sure this is X and this X double is 2X here. So CBD is half of this 2X is X. So CBD equal half of 2X is X. Therefore CAD equal CBD. Angles in the same segment are equal. Question number 4. Prove the opposite angles of a cyclic quadrilateral sum to 180. Right? So cyclic quadrilateral means a quadrilateral's all four vertices are going to be on the circumference of the circle. So just a normal quadrilateral means it's a four-sided shape. Cyclic quadrilateral means all four corners are going to be on the circle. So here ABCD is a cyclic quadrilateral. So we need to prove angle A, angle C add up to 180. So let BAD is X, BAD is X, BOD is 2X, BOD is 2X because center angle double the circumference angle. Reflex angle BOD, so reflex angle means more than 180. So BOD, obtuse angle is 2X. Reflex angle of BOD is 360, take away the 2X because angles around a point add up to 360. So reflex angle BOD is 360 minus 2X. Then BCD is half of the reflex angle BOD because it's the center angle. So you need to write the reason: center angle double the circumference angle. So I missed to write this one, so I just add this again. So circumference angle. So Half of 360 minus 2x is half of 360 is 180, half of 2x is minus x, so angle BCD is 180 minus x. Now if I add BAD plus BCD add up to x plus 180 minus x and minus x is cancelled, is going to be 180. So therefore opposite angles of a cyclic quadrilateral add up to 180. The last theorem, question number 5. Prove the alternate segment theorem that the angle between the tangent and the chord at the point of the contact is equal to the angle in the alternate segment. So we got to understand what is alternate segment. So the segment means this is the segment. I'm shading this region or arc. This is called segment. So that is the segment, and this is tangent. DCE is the tangent and CB is the chord. So this angle I marked here X, it's going to be alternate segment, means the alternate segment here starting, this is the alternate segment. So in this alternate segment, wherever the A position is, that angle is going to be X also. So that is the theorem. So angle between the tangent and the chord, which is the X, equal to the alternate segment angle. Wherever the A comes, that alternate segment is going to be equal to X. How to do this one? Let BCE equal X. BCE equal X. I start from here. Then DCE is a tangent. So OCE is 90 degrees because tangent and radius meet at 90 degrees. That is correct. BCO is 90 minus X. Triangle BOC is an isosceles triangle, right? So OB and OC equal. OBC also 90 minus X. BOC is 180 minus, you need to add the 90 minus X plus 90 minus X. Then you need to add, so what I'm going to do is I'm going to release the bracket. So 180 minus 90, minus time minus is plus X, minus 90 plus X. So 180 minus 90 is 90, 90 minus 90 is 0, X plus X is 2X, 2X is the answer, that is the BOC. If BOC is 2X, automatically BOC is equal to 2 times of BAC. Center angle is double the circumference angle. So therefore, BAC is half of BOC, which is half of 2X, which is X. So we already proved that is X. So BCE, which is the tangent and the chord angle, equal to alternate segment angle, which is BAC. So we already proved alternate segment angles are equal. That is the end of the tutorial. So we left 2 theorems need to be proved. I think one is a tangent, 2 tangents drawn from outside of a point to a circle are equal length. We need to prove that one. And the last theorem is you need to prove the tangent and the radius are 90 degrees, right? So you got to practice with those 2. I'm not covered in this tutorial. We will cover that 2 theorems in the revision times when we're preparing for the exam for GCSE. And this video tutorial specifically for the first 5 theorems. I hope you like the video. If you do like the video, please give us a thumbs up and subscribe to our channel. If you like this video and if you think this video is going to be benefit for your siblings or friends or year 10s and year 9s, please forward the link to them to subscribe and watch this video. And repeatedly, if you can watch the video and understand the technique behind the proof of circle theorem, this topic is considered as the level 8 and level 9, and it's a little bit of tough topic, but if you practice more you can understand the theorem. And I will definitely prove the remaining 2 theorems during the revision session. All the best. See you in the next video.